So here the force is horizontal to the ground, that is basically parallel to the ground, that is horizontal force. So we have a parcel of weight 10 Newton, so we don't have to use mg Newton, so already it is in Newton. Lies on a rough plane, so we know that the plane is a rough plane. The angle is 30 degree to the horizontal, and the horizontal force is p Newton. We don't know what the value of this is. Acts on the parcel, and it is shown over here. The parcel is in equilibrium and is on the point of slipping up, so it is about to move up. That means friction will work in the opposite direction. So this is in limiting equilibrium, about to move up. So we know that the normal reaction, the normal reaction is given. The normal reaction of the plane on the parcel is 18 Newton. This is given. Usually it's not given. And coefficient of friction is unknown. So let's draw this first. So we can do this. This is 30 degree. So we have an object over here. So this object, it has a weight of 10 Newton. So we don't have to give g over here. So now we can see this is normal to the plane, and this one is along the plane. So this is going to be mg, meaning 10 sine 30, and this is mg, meaning 10 cos 30. Now in this particular math, what we know over here is the reaction force. The normal reaction force is 18 Newton, and this is given. So this is 18 Newton. Now we know that there is a horizontal force. So the horizontal force is this one, and because of this horizontal force, we're going to have two components of this force, one normal to the plane, another one is along the plane. So the one that is normal to the plane is going to be like this. It is going to be this one, and along the plane is going to be like this, one. So if this is 30 degree, this one will also be 30 degree, this will also be 30 degree, alternate angles. So 30 degree, like a Z, it will be like this. So if this is 30 degree, this is going to be P cos 30, and this is going to be P sine 30. That's the component. Now as we know, if this is going to be along the plane, then it is going to move up, slipping up. It is about to move up. That means whatever friction that is going to work, it is going to go in the opposite direction to motion. So the friction will be in the opposite direction to motion. Mu is unknown, r is 18, so 18 into mu. So that is going to be the maximum friction. So now that we have this entire component given over here, it looks a little bit messy. We have to find the value of p. So we have to look for p, which is best, along the plane or normal to the plane. So obviously normal to the plane is best, because along the plane mu is also unknown. So let's take normal to the plane. So components normal to the plane, that means upward is 18 Newton and going downward is P sine 30 plus 10 cos 30. So this is going to be 18 minus 10 cos 30 divided by sine 30 equals to P. So therefore P equals to, so this is 18.7 Newton, meaning 19 Newton to two significant figure. Now question number B. In question number B, we have to find the value of mu. So we are going to take along the plane. Along the plane, we have pulling it downwards is 10 sine 30 plus mu r is 18, equals to, pulling it upwards is P cos 30. The value of P is, let me put 18.7 cos 30. So here we have to find the value of mu. So in order to find the value of mu, so the calculation is going to be 18 mu equals to 18.7 cos 30 minus 10 sine 30. Therefore mu equals to 18.7 cos 30 minus 10 sine 30 divided by 18, and mu equals to 0.62 is the coefficient of friction. Okay, Now we have a common question. So if the force is removed, we have to check whether or not the object will remain in place or whether it is going to move. So if the force is removed, so this is what's happening. So in question number C, so if this is the force, horizontal force, it's removed. So we have this angle, we know this is 30 degree. So this is 10 Newton. So the components would be mg sine theta, so 10 sine 30, and this is going to be 10 cos 30, and we know the reaction force. Now the reaction force, the question is it going to be the same or not? It's not going to be the same, because friction is something that is a property or a quality of the surface, but the reaction force immediately changes when any force is changed. So this time we don't know what the reaction force is, because previously the reaction force was being actually balanced by other forces. One of the forces was a component of the force P. So this time we don't know what the reaction force is, but this is, if there is no force, this is going to try to move downwards. So friction is definitely going to be opposite to motion. So mu is definitely constant, because mu is based on the surface quality, not on any other force. Reaction force is unknown. So now the first thing we have to do over here is normal to the plane. So we have to find the component. So r equals to 10 cos 30. So that means r equals to 10 cos 30 is root 3 by 2, which is 5 root 3. So this is the value of r. Now along the plane. So the main idea of along the plane is not to assume that they are equal, because we cannot assume. We have to show whether the object is staying or not. So let's, along the plane, let's see what the value of friction is. Friction is 0.62 r, and r is 5 root 3, and this turns out to be, so this is going to be 5.37 or 5.4 Newton. So the friction, maximum friction, has a total load capacity of 5.4 Newton force. It can support that. So let's see what is the downward force. So here, downward force is 10 sine 30. That means 10 into sine 30 is half. So it is going to be 5 Newton. So the downward force is 5 Newton, and the friction has a maximum capacity, or maximum friction is mu r. It is 5.4 Newton. That means the friction can support this object. So the object will not move. So object will not move. Friction. So this is maximum friction, and it is mu r.